talk is called Heap Spray Detection with Heap Inspector. Please give a warm welcome to Aaron LeMasters.
Hi everybody, thanks for coming to the talk. I'm Aaron LeMasters. I've worked at Mandiant about 2 years. My job primarily involves malware analysis, writing code for our agent, for our product, and various R&D projects. Just a quick reminder to please complete the speaker feedback surveys. Black Hat tells me those are pretty important, so be sure to fill those out. You should have gotten one with your registration bag and all that stuff. So the purpose of this talk is to go over Heap Inspector. It's a free tool. It's going to be released on our website sometime this evening, so download it and check it out. Please send me any comments, any feedback, questions, ideas, things like that. Appreciate it. We have a forum as well, so if you want to post any comments there. So the idea for this tool came from a conversation I had with a friend of mine, Artem. Basically, we were talking about how antivirus and HIP solutions don't detect heap sprays. It's a very common attack technique. It's used in literally every document-based exploit in the wild out there. And it's a pretty predictable attack, and it repeats data on the heap, and it should be something that be pretty easy to spot. If this data is repeated, you could hash it and then report a repeating pattern, maybe alert that as an anomaly. So this tool kind of grew out of that idea, and then it kind of took a life of its own, some visualization features and searching and things like that, which I'll go over in a second. The main idea is to kind of audit an application and see what it's storing on the heap when it runs. Some related research that, I would say related, but it's really loosely related because these are much more academic, thorough papers. Stride and Nozzle are both more dynamic analysis, binary instrumentation, things like that to detect and prevent heap sprays. EMAT is it's actually a supported Microsoft product to remediate or help remediate your system, prevent heap sprays from occurring through various built-in operating system security features. And Heap Locker is a tool by Dadier Stevens, which is more closely related to this tool, but it also is a real-time and helps prevent a heap spray from occurring. So what can you do with this tool? In this talk, since we only have 20 minutes, we're going to talk about two primary use cases: detecting, visualizing a heap spray after it's occurred, and searching for personally identifiable information such as social security numbers, credit cards, Skype conversations, that type of stuff. There are some other uses that I thought about. Haven't really implemented much in the tool to support this, but reversing memory structures. So for example, a Skype conversation is it's a very obvious pattern. You could easily write a signature to detect the actual structure that a conversation is stored in memory. Debug heap anomalies if you're debugging your application, and vulnerability research. So if you have a use after free vulnerability you want to try to track through the heap, that's something we could possibly implement in the tool. So the features are: you view the heap allocations in a spatial arrangement. There's a hex editor to view the heap and do searching and regular expression matching and things like that. Export heap chunks to use in other tools. And it comes in two forms: a command line executable and user interface. So very basic Windows heap mechanics. If you want a real overview of internals of the Windows Heap Manager, check out Chris Valisek's talk on the low fragmentation heap. But basically every process has a default process heap and a number of private heaps. The heaps are made up of one or more segments. A segment is made up of numerous chunks, and the chunks have the actual data you care about. Each one of these are represented by a Windows data structure that has some meta information, but we're not going to focus on any of that. This is really all you need to understand how Heap Inspector works. So what is a heap spray? Everybody here probably knows what a heap spray is, but it's basically a technique to stage shellcode. It's usually accompanied by some type of memory corruption vulnerability, and it's used to increase the reliability that that exploit will succeed, and they'll get code execution on the system. It's very common in engines such as Flash and Java, things that need executable code to run. Here's a number of CVE vulnerabilities that are accompanied with a heap spray. So we use to advantage the fact that heap spray repeats its attack data hundreds of times on the heap. It kind of stands out. It's pretty obvious to recognize. So that's where the heap hash map comes in. This is one of the main features of the tool. So what it does is it walks all the chunks in every heap in the process, and for all the chunks that match a frequency and threshold that you specify, it will basically paint it on a bar, and all of the chunks that have the same CRC32 will be painted the same color. So as you can see in this screenshot, this is a successful heap spray in Adobe Reader. It stands out pretty obvious that there's a heap spray, and the addresses along the bar are the actual random chunk addresses that are in the heap. So this one has 515 megabytes of used space, 46,000 chunks, and you can see the beginning of the NOP sled. That's part of one of the chunks in the heap spray. After you click on one of the links, you'll see the hex editor view. It'll highlight the shellcode. At the bottom, the shellcode is highlighted for you. The second feature of the tool is the heap data map. This is looking for the personally identifiable information. So you can define your own regular expressions. The tool comes with a number of regular expressions like social security number, email, GUIDs, MD5s, things like that. Basically applies the regular expression across all the strings in the heap. It also has byte pattern searching, so if you want to look for PEs, you can define things in the PE header to scan in the heap. You'd be surprised how many portable executables are actually in Skype's heap. And as I said, you can do searching for string, Unicode or ASCII, byte patterns, and regular expressions. This is the Skype conversation that resembles a data structure that could be scanned for. And here's the overall user interface. To the left is the list of active processes. To the right is the canvas where the maps are drawn. And there's two tabs, one for the heap hash map and one for the data map. So a quick overview of how the tool works. It injects a DLL using standard DLL injection. That's virtual alloc, write process memory, and create remote thread. Very standard DLL injection. There is support in the tool for reflective DLL injection technique that Stephen Fewer documented, which basically allows you to, independent of the Windows loader, to fix up and load your DLL in another process. So the DLL I inject acts as a server, receives and sends messages using a named pipe. Uses C# interop, standard Win32 heap walking APIs, though there is raw parsing code that's implemented that walks the PEB to obtain the list of heaps and chunks. So you may ask, why do you inject in the process? Why don't you just use existing Windows APIs? Because an external process can access another process' private heaps without being in that process address space. So here, a short list of some of the technical challenges to doing this. DLL injection by itself has a lot of instability issues because fundamentally you're turning a potentially single-threaded application into a multi-threaded application. As soon as you call create remote thread, there's now two threads assigned to that process. So there could be synchronization issues, deadlock conditions when you're accessing the heap, things like that. Also, using the standard DLL injection, once your DLL main is called, every other DLL main in the process loaded list is called as well. So there could be unintended side effects if other DLLs have initializations in their DLL main routine. Another huge hurdle I ran into was sandbox processes like Chrome. So I just gave up on Chrome and decided that this tool will not support Chrome because even if you succeed in injecting, which you have to use reflective injection to get loaded, you're in a completely isolated, least privileged token context. You're in a job object, you're in a different desktop. There's all these measures that prevent you from doing anything. I couldn't talk to the pipe that I'd set up or anything like that. So the only solution around that is to get some type of privilege escalation in there, and I wasn't going to do that for a free tool. Definitely not worth it.
Can you speak up a little bit?
Sorry. So other issues, in Vista, Microsoft introduced session separation, and that prevents you from injecting from one session to another. So users are usually in session 1 and services are in session 0. So the undocumented function nt create thread x, which is undocumented by Microsoft but well documented on the internet, that allows you to inject across sessions. Also, WoW64 emulated processes are a bit of a pain, so there's a little trick you got to do to get the addresses you need in a 32-bit process if you're running from a 64-bit process. Structured exception handling is much better than C++ exception handling for access violations, so something to remember. And here's a cool one, is smss.exe. It doesn't have kernel 32 completely mapped in, so if you inject code in there that needs that library, you'll blue screen the box because SMSS is marked as a critical system process, and if you cause an access violation in it, it's going to destabilize the system. So here's a quick demo. It appears to be stuck. That's awesome. All right, so while this reboots, I'm going to go to the rest of the talk. So you may say, well, I can already do that with a number of other tools like debugger or some memory analysis capabilities, but the debugger requires some pretty advanced skills and knowledge of heap internals and things like that. Instrumentation using like pen or some other type of binary instrumentation is what some other tools use, but that requires some heuristics, disassembly, code analysis, and it introduces an overhead and a false positive and negative rate that may or may not be acceptable. Same with memory analysis, and an additional disadvantage of memory analysis is that it's a smear and it's stale and it's not as real time as a debugger or a tool like Heap Inspector. Again, some vulnerability research applications in the future, real-time detection like Didier-Stevens' Heap Blocker tool, and then I want to be able to accept memory images as input instead of just a live system. References, Mandiant is hiring, plug if anybody's interested in working at Mandiant, a bunch of positions. Come talk to me in this feedback survey, and let's see if this is going to work. Oh, that's why. So any questions while you wait for this to boot up? No. Good question. I think so, yes, eventually. It isn't right now, but. The question was, is it going to be integrated into Mandiant's existing products, commercial products? And the answer was probably yes. Demo guides are not nice today. All right, well, this is what I'm going to do. If people will stick around for just another minute. No, that's not what I wanted to do. Oh, wait. Okay, I think we're good. Okay. And files. Okay, so here's a malicious PDF that forms a heap spray. Unfortunately, the only samples I could find actually crash Adobe, so this is going to crash, but we can still check out the heap hash map. So we should see the spray start here. Or we could have demo fail. Okay, so you see the spray occurring. The application will probably crash here in a second. But if we click on the process, you mouse over, you can see the NOP sled. And if you click on one of these links, after a few seconds, it will populate the shellcode. And I think this one is a weird spray where the shellcode isn't actually at the end, it's somewhere in the middle. Nope. Okay. Can't inject into the process. But the heap data map is pretty self-explanatory. You see it searching the patterns, and now it's creating a list of all the strings in the heap and applying the regular expressions to each one. So you can mouse over all the different hits. It's not able to draw a label for every hit, so that's one drawback, but you can go to the search tab and specify the regular expression here, and then search the heap that way. And this is where you specify all the settings. So the frequency and threshold I talked about. It's a what? Right. It's not a like a HIPS type detection prevention tool. It's a post-mortem analysis tool. And you can define regular expressions here, include them in the data map, and that's it. Thanks for sticking around for the fail demo.